Hi, everyone, and welcome to stop number 4 on this metamorphic field trip. All right, so this is stop 4. This is the Pumpkinvine Creek Formation, and this particular outcrop photo comes from the I-575 location near Canton, Georgia. Now we focus on this outcrop first, instead of the other outcrops in the field guide, such as the 2 type localities for this unit, because the I-575 location has the best examples of metamorphic mineralogy and textures for this unit. It's quite spectacular, the difference between the gneiss at this outcrop and the amphibolite at the next outcrop that we'll describe from one of the type localities. All right, so this locality is located on I-575, which is right here near the town of Canton, Georgia. The Pumpkinvine Creek Formation is part of the Dahlonega Gold Belt, which is this orange unit, and is part of the Eastern Blue Ridge. So where we left off with stops 2 and 3, we were in the Central Blue Ridge of North Carolina, looking at high temperature granulite facies rocks, metamorphosed during the Taconic, primarily. Before that, we were looking at Taconic metamorphism in the Ducktown area. So now we've moved to the Eastern Blue Ridge, making our way down to where we have the majority of our data and material in Alabama. All right, so how to get here? So if you're doing this field trip in order, stops 1, 2, 3, and now 4, you will head west from Winding Stair Gap on US 64. You'll turn onto 69 South, then go to US 76, and then eventually that will turn into I-575. Now, because the outcrop is on the northbound side of the interstate, that means you'll have to make a U-turn if you're approaching from the north. So if you're in the southbound lane approaching the outcrop, you'll have to make a U-turn or turn around at exit 16B, which is right here. This allows you to safely pull off well off the road, right at our outcrop of interest. Now, it's important to note that this is a very busy highway and can be particularly busy during rush hour. So we recommend not going to this outcrop during rush hour or peak traffic times. And do not take large groups to this location. Large groups such as multiple vans or even a bus will distract drivers and could cause accidents. Also, the more people at an outcrop, the more dangerous it can be, the more people you have to keep an eye on. So please be careful, be very mindful of the cars. And if you get a visit from a state trooper or local police, follow the directions and please leave if they ask you to. All right, so this is a Google Earth or Google Street View showing the approach to our outcrop here. Now, this is the outcrop of the Pumpkinvine Creek Formation that we described in the field guide and here in this video. However, if you look off into the distance, you will see another outcrop here. Now, this outcrop way back here, that's actually the Canton Formation. It is not the Pumpkinvine Creek Formation. The dashed line showing the boundary between these 2 units, that is a very rough estimate of where the boundary is. It more or less runs parallel to I-575 right here. So be very careful that if you visit this outcrop, which outcrop you're at, because that's 2 very different units. All right, so let's look at some background and tectonic setting for the Pumpkinvine Creek Formation. The Pumpkinvine Creek Formation is composed of primarily mafic and felsic gneisses, with some minor schists and metasediments. The mafic and felsic gneisses are interpreted as bimodal volcanics, deposited in a back arc setting near the southeastern Laurentian margin. The mafic gneisses are correlated with the Hillaby greenstone in the Alabama Western Blue Ridge based on petrogenetic data and trace element data by Holm, Denoma, and Das 2010. All right, so prior work indicates that the igneous crystallization ages for those mafic and felsic gneisses was around 466 to 462 MA. The only age we have that documents any type of metamorphic history for this particular unit is from a hornblende argon-argon cooling age from an amphibolite. And this age is 313 plus or minus 10 MA. Now, this is not a published result. In fact, it was a personal communication within McConnell 1980. So as such, we have to treat it with a little bit of skepticism, or at least hold back any interpretation based on this age, at least major interpretation, until we have a better constraint on the metamorphism for this area. We cannot actually trust this 313 age because it was just a personal communication. So again, take it with a grain of salt. Regardless, this is the only age we have to go by for now. All right, so the timing of peak metamorphism is unknown. So even if this were a real age, if we knew this was accurate, if we were able to interpret this data and critique it ourselves, this 313 age would still be a cooling age for hornblende and not a peak metamorphic mineral age, such as garnet, for example. So we don't know the timing, really, and we also don't know the conditions reached for this particular unit. We don't know the pressure or the temperature. All right, so let's look at the outcrop in more detail. All right, so this is the same outcrop on I-575, looking at a big chunk sticking out from the sawdust from where they destroyed some trees along the shoulder of the road. And you'll notice that there are large porphyrolast of garnet that get up to about 1.5 centimeters in this outcrop. There's also very large hornblende in this outcrop as well. And overall, this outcrop is named a gneiss. This is a more close-up view of this same outcrop, showing a rotated amphibole splay or hornblende splay, indicating synchronous crystallization of that hornblende with deformation, or the hornblende growth was pre-deformation. This particular hornblende is 3 centimeters across, so they're quite large. And the individual garnets in this outcrop, like such as this one or this one over here, are about 1 centimeter. You can actually view a 3D image of this outcrop, of this sample right here, by looking at or using your phone to go to this QR code. All right, so looking at the other side of that QR code sample, so the other half of that cut face, we see a beautiful rock with gorgeous textures of garnet with rotation tails upon them. We also have storolite that helps define our foliation in this sample. The storolite is the tan honey yellow color in here, kind of a honey brown. So that's that storolite right here. We also have quartz and calcite veins that cross-cut the foliation locally throughout this outcrop. There's also kyanite, which I will point out on the following image within this sample. So this sample is actually a kyanite storolite garnet hornblende gneiss. All right, so looking at this sample with our microscope here, we can see those large hornblendes. In this image, it has smaller garnet fragments or grains. In panel B, we actually see some staurolite cropping up, as well as some smaller clinoamphibole or hornblende, as well as some orthoamphibole in here as well, which is quite minor in this rock, but there is some present. More importantly, we see staurolite that is actively being has been overgrown by the garnet at its rim, but we also see it preserved in the matrix here as well, but it's largely anhedral. Panel D shows a garnet porphyroblast, shown here, and in its pressure shadow is some kyanite that forms a sharp boundary with this garnet porphyroblast. This indicates that the kyanite is texturally late and that garnet growth occurred either at the same time as kyanite growth or predated it. So another set of data we have for this rock are some elemental concentration maps that we collected using an electron microprobe. So in this image, this is an image just showing silica concentration within this particular screenshot or image or view of this rock. So here we have a garnet porphyroblast, shown here. Outside of it, we have quartz, which is this yellow, the bright yellow in here is all quartz. The quartz helps show the foliation very well, and you notice that the foliation wraps around these garnet porphyroblasts. The quartz also shows up well in the pressure shadows of these garnets, such as up here, as well as inclusion trails within the garnet. Now, these inclusion trails are a rotated fabric that the garnet overgrew, and in this case, they continue off into the matrix. Another feature we can notice here is that there is an overgrowth of garnet along this side without any inclusions. So this could indicate either two pulses of garnet growth or a hiatus in garnet growth, where it included material over here initially, and then either stopped and then began growing again, or it was a continuum of garnet growth where we have no inclusions preserved or included within that garnet. This could indicate a big temporal story, as in maybe the core is one age, maybe this overgrowth is a different age. All right, so constructing a mineral assemblage diagram, or MAD, for this sample, we can see that the garnet in reaction occurs down here at about 550 degrees Celsius. So that's our first occurrence of garnet. From there, we enter staurolite stability in this yellow region. We cross the ilmenite stable reaction. So beyond this blue line, rutile is stable. We then cross into orthoamphibole stable region right down here. And then we cross out of it again into our peak assemblage field, which is garnet, kyanite, biotite, hornblende, plagioclase, quartz, and rutile. So this is our peak assemblage. Now this peak assemblage occupies a very large range of PT space, so our peak conditions are not very well defined for this sample. These conditions are 610 to 715 degrees Celsius and 8.5 to 11 kilobars. This indicates up to 150 degrees Celsius of heating and up to 4 kilobars of loading. Now, this PT path will be refined in the future using additional thermodynamic data, as well as thermobarometry. But for now, it does a pretty good job of reconciling what we see in the rock versus what the model predicts. All right. So let's transition to a type locality for the Pumpkinvine Creek Formation. And I said earlier that the I-575 location near Canton is more spectacular from a metamorphic standpoint. Now, the reason I said that is because the mineralogy, i.e. those large garnet, the presence of storolite and kyanite, is more useful when constructing pressure temperature time paths than, say, a amphibolite without any of those minerals. Unfortunately, that's what we primarily observe at both the type localities for the Pumpkinvine Creek Formation. So this location, with Harold Stowell here for scale, is located just a little bit south of Cartersville, Georgia, near Lake Allatoona. All right, so we have now moved a little bit farther south and west from our Canton, Georgia stop for Pumpkinvine, down a little bit to about right here or so. It's a little bit to the southwest. All right, so at the type locality at I-75. So we're going to visit this locality here, where we're now here. There's another type locality located on I-41. But to get to this location, you need to take I-575 south to exit 7. From there, take Georgia 92 south to I-75. The outcrop will be on the right, so you don't need to make a U-turn, on the northbound side near Lake Allatoona. Same deal with safety as the prior stop for Pumpkinvine. Be very mindful of cars. This particular curve is much sharper than at I-575. So that means that the cars come around and appear more suddenly, and you might not have time to react. So be very careful when getting back on the highway at this location. Again, we don't recommend taking large groups to this stop. Okay, so this is what the outcrop looks like. It's well foliated. This particular portion of the outcrop is more schistose, has more of a schistosity than an isosity. In general, the rocks at this location are fine to medium-grained amphibolite, composed of chlorite-bearing amphibolite interlayered with sparse garnet hornblende plagioclase gneiss. Now I've underlined sparse here. I mean it. It is sparse. You have to really hunt to find garnet at this location. All right. So one of the reasons that we brought you all to this virtual location for Pumpkinvine Creek is the fact that there have been reports of relict amygdules, pillow basalts, as well as some phenocryst at this location as far back as McConnell 1980, and then again more recently in Holm Denoma and Doss 2010. Now these features are obviously obscured by later deformation and metamorphism, but we invite you all to look for these features and make your own inferences on whether or not metamorphism has completely obscured these features at these outcrops, and decide for yourself if you agree. All right. So as I said earlier, the trace element data supports a back arc basaltic protolith for this outcrop. So even if you cannot identify amygdules or pillow basalts or cannot convince yourself that they are here, the trace element data has confirmed it, and these are basaltic rocks deposited within a back arc basin. This field outcrop photo shows a folded unit of the more massive basaltic or mafic material, less schistose, with some quartz veining down here at the bottom and more quartz veining up here at the top. This photo shows another quartzo feldspathic vein in this case that has been passively folded along with its bounding amphibolite units. All right, so where does this fit into the big picture? Where does the pumpkin vine fit into this story? Well, we don't know quite yet what the timing of the amphibolite facies rocks when they were metamorphosed within the Pumpkinvine Creek Formation. That is currently underway at the UA Rad Ice Lab. The Pumpkinvine Creek Formation that we were looking at just now, or earlier in this presentation, the I-575 location was right here within the kyanite storolite zone on this map, this brown patch. The other location, I-575, is more down in here. So, could the timing of the metamorphism within the Pumpkinvine Creek Formation be similar to that exposed farther south along strike? As of yet, we don't yet know, but remember, we do have that 313 MA hornblende cooling age that even though it's not published, we can make some inferences under the assumption that it turns out to be accurate. So if that age is 313, and we had igneous crystallization unit of these units at 460, then the Dahlonega Gold Belt or Pumpkinvine Creek Formation would not have been metamorphosed during the Taconic and likely would have been metamorphosed during either the Neo-Acadian, Acadian, or Alleghanian events, possibly correlating with the Ashland or maybe even the Wadawi groups farther down here in Alabama, which we will see later on in this field trip. All right, that concludes our Pumpkinvine Creek Formation field trip stop. Next up, we'll be seeing the Ashland supergroup near the town of, or near the unincorporated area of Micaville, Alabama.